Will quantum computers outthink human brains? Your brain is frankly a miracle. Right now, 86 billion neurons are firing away, processing these words, keeping your heart beating, and remembering what you ate for breakfast. And here's the kicker. It's doing all of this using less power than a dim light bulb. It is the undefeated champion of efficient, flexible intelligence. But now, a new challenger is stepping into the ring. A challenger that doesn't play by the normal rules of physics. It doesn't think like us. It doesn't learn like us. And it promises to solve problems that would take our fastest supercomputers billions of years to crack. This is the strange new world of quantum computing. So, the question is, in the fight for the ultimate thinking machine, what happens when our biological brain goes head-to-head with a machine that operates at the very edge of reality? You've probably been told you can't be in two places at once, but what if you could? What if a computer could explore millions of possibilities, not one by one, but all at the exact same time? This isn't science fiction. This is the bizarre truth of a quantum computer. And understanding this single mind-bending idea is the key to figuring out if these machines will one day truly outthink you. Section 1. The reigning champion. The human brain. Before we jump into the quantum realm, let's give the current champ its due. Your brain is the result of millions of years of evolution. It's a masterpiece of biological engineering. It's not just the 86 billion neurons that matter, it's the connections they make. Each neuron can form thousands of links, creating a web with trillions of synapses. This isn't a rigid circuit board, it's a living, breathing, dynamic network. This massive parallelism lets you do incredible things. Think about driving a car, you're steering, listening to music, maybe even planning dinner all at once. That's a level of multitasking that would make a normal computer crash. Your brain excels at recognizing patterns, learning from incomplete information, and adapting on the fly. This ability to constantly learn and rewire itself is called neuroplasticity, and it's the brain's true superpower. And the power consumption, it's almost laughable. The brain performs an estimated quadrillion operations per second, which puts it in the same league as the world's top supercomputers. But while a supercomputer fills a warehouse and needs enough electricity to power a small town, about 20 megawatts, your brain does it all running on just 20 watts. It's millions of times more energy efficient. It also holds a mind-boggling amount of information, with a memory capacity estimated to be around 2.5 petabytes. The brain is the ultimate jack of all trades. It handles logic, emotion, creativity, and social cues all at the same time. Sure, it's slow at long division, but it can write a song, discover the laws of physics, or fall in love. It is the gold standard for general adaptable intelligence. Section 2. The challenger from another dimension, the quantum computer. Now, meet the challenger. Quantum computers are not just faster versions of your laptop. That's like saying a submarine is a faster version of a car. They are a completely different kind of machine, running on the spooky principles of quantum mechanics. Let's try an analogy. Imagine a classic computer is a librarian trying to find a specific fact in a massive library. The librarian has to check each book, one by one. They might be fast, but it's a step-by-step process. A quantum computer, on the other hand, is like a magical librarian who can read every single book in the library at the same time. It finds the answer using a completely different, almost impossibly parallel method. How does it do this? It starts with the qubit. A classical computer bit is either a 0 or a 1. A qubit, however, can be a 0, a 1, or both at the same time. This weird property is called superposition. Because of superposition, just a handful of qubits can represent and work through an exponential number of possibilities at once. Then you have entanglement, what Einstein called spooky action at a distance. You can link two qubits so that the state of one instantly affects the other, no matter how far apart they are. This incredible connection creates a computational power that's hard to fathom, allowing quantum computers to solve very specific, very hard problems. They aren't built to check your email or stream movies. They are specialists. Think of tasks like perfectly simulating a new molecule to discover a drug, breaking the world's toughest encryption, or optimizing a global shipping network with millions of variables. For these jobs, a quantum computer's ability to look at every possibility at once gives it an almost unfair advantage. CTA. If the idea of a computer exploring millions of realities at once just bent your brain a little, let us know in the comments what other big scientific ideas you'd like to see broken down. And if you're enjoying this, maybe think about subscribing for more. Section 3. The head-to-head clash. So if we put these two side by side, who wins? Well, the answer is, it totally depends on what you ask them to do. In a race of pure, specialized math, a mature quantum computer would leave the human brain in its dust. For the problems it's good at, the speed up isn't just a little bit faster, it's exponentially faster. For example, in 2023, Google's Sycamore quantum processor ran a calculation in just a few seconds. It's estimated that the world's most powerful supercomputer, Frontier, would need about 47 years to complete that same task. The human brain wouldn't even know where to start. But flip the script. Ask the quantum computer to recognize your friend's face in a photo, get the joke in a sarcastic comment, or whip up a new recipe from whatever's in the fridge. It would fail spectacularly. The brain's general intelligence, its knack for learning from experience and dealing with uncertainty, is something current quantum algorithms can't even begin to imitate. And then there's the massive practical problem. The brain is the undisputed king of efficiency. Today's quantum computers are energy-hungry beasts, needing huge amounts of power and cooling systems that keep their fragile qubits stable at temperatures colder than deep space. So, will quantum computers outthink us? For a very narrow but very important set of problems, they absolutely will. They are the ultimate number crunchers. But they don't have the flexibility, the creativity, or the general smarts of a human brain. They run algorithms. They don't learn or grow in a biological way. They aren't a rival brain. They're an incredibly powerful new tool for our brains to use. Section 4. The weird twist. Is the brain itself quantum? But this is where the story takes a sharp left turn into the bizarre. What if the line between our brain and a quantum computer isn't as solid as we think? There's a growing and pretty controversial field called quantum biology that's asking a wild question. What if quantum mechanics is happening inside our own heads? Some scientists are proposing that tiny structures inside our neurons could actually support quantum effects. These theories suggest that things like short-term memory, or even consciousness itself, might have a quantum component. This is all highly speculative, but it's one way to try and explain how humans still manage to outperform computers on tasks that require creativity, a sudden flash of insight, or making a gut decision. Could our aha moments, or the very feeling of being me, come from quantum weirdness? Researchers have even suggested experiments to test these ideas, including one that would try to entangle a human brain with a quantum computer. It sounds like a movie plot, but it shows just how much we still have to learn. If there's any truth to this, it means our brain might be using a type of computation that's way more powerful than we ever imagined. It would mean we aren't just competing with quantum computers, we might be one. So back to the big question, will quantum computers outthink human brains? The answer is more interesting than a simple yes or no. This isn't a story about replacement, it's a story about partnership. Quantum computers are not coming for our consciousness or our general intelligence. They are showing up as amazing tools that will massively boost our own abilities. They'll help us design life-saving drugs, create new materials for clean energy, and solve logistical puzzles that are currently beyond our reach. They will take care of the kinds of brutal calculations the human brain was never designed to do. That will free up our unique, creative, and adaptable minds to ask bigger questions, chase down bigger ideas, and make sense of the answers these incredible machines give us. The future isn't a race between humans and machines. It's a collaboration, a future where the most powerful computer we know, the one between our ears, is supercharged by the strangest and most powerful technology we've ever dreamed up. The real question isn't whether they'll outthink us, but what incredible thoughts we will think together. What do you think will be the first huge discovery made with a quantum computer? Curing a disease, tackling climate change, something else entirely? Drop your thoughts in the comments below. And for more explorations into the future of science and tech, make sure you hit that subscribe button. Thanks for watching.